The vertices of a regular hexagon lie on a circle with center 0 and the radius 5 centimeter. That is the center 0. That is the radius 5 centimeter. Also, angle between these radii has given, which is 60 degree. Work out the shaded area. That is the shaded area. We need to find out this shaded area. Give your answer in the form a pi minus b square root of c whole divided by 12, where a, b, c are integers. Here we have a sector, and in the sector we have a triangle. That is a triangle. So if I get the area of the sector, this big sector, and if I subtract the area of the triangle from this sector, I can get the specific area, which is the shaded area. So for that purpose, we need to know about how we're going to find out the area of the sector. Area of the sector is actually depends on how much angle do we have, because we know the angle in a circle is actually 360 degrees. That total circle is actually 360 degrees. So that's going to be 360 degrees. It means 60 degree out of 360. That would be the angle. We can get the ratio of this angle and multiply this by area of the circle. We can get the area of this sector. Actually, this sector, that is the sector. So I'm going to write here the formula for area of the sector is equal to the theta, which is given. In this case, the theta is given 60 degrees out of 360 degrees multiplied by the area of the circle. And because we want to show the answer in this way, so I need to include the pi here. So theta divided by 360 times area of the circle is pi r squared. So I don't want to cancel this pi because I need this at the end of the question. That is the area of the sector. What is the area of the triangle? So actually we have isosceles triangle here, because both the sides, that is 5 centimeter, that is 5 centimeters. So we have isosceles triangle. We need to know how we're going to get the area of the isosceles triangle. So there are several ways to find out the area of the isosceles triangle. It depends upon what kind of information do we have. So in this case, we have two sides and the angle between these two sides. I'm going to write here formula for area of an isosceles triangle. So first thing, if the base and the height is given of the isosceles triangle, so we use the formula for area is half times base multiplied by height. If we are given the three sides of isosceles triangle and the angle is not given, so then we have another formula, half times square root of first side squared minus the second side squared divided by 4, and that is also in square root, multiplied by the second side. If the length of two sides are given and angle between them, this is the similar case we are doing right now. The area would be 1 over 2 times first side multiply by the second side and the sine of this angle. In this case, which we are doing, the angle is 60 degree and the side B is 5 centimeter, side A is 5 centimeter. Two angles and one side is given. Then the formula would be the one side squared and sine and the angle of the opposite side, because the two angles are given. So second angle divided by 2 multiply by sine of first angle. If the isosceles triangle is a right angle triangle, base time height multiply by 1 over 2, half times base time height. Because that is the isosceles triangle, it means base and the height is similar. That is the base, that is the height. It means whether they are AA or whether they are BB, they are similar because they have the same length. That's why that is isosceles triangle. So we could write here 1 by 2 if base and the height is same. So I can write this a times a. That's going to be 1 by 2 a squared. Which formula we need to use where the length of two sides is given and the angle between them is given. By subtracting the area of the triangle from the area of the sector, we can find the shaded area. So first I'm going to find out the area of the sector. Theta divided by 360 times pi r squared, where theta is given 60 degrees and r is 5 centimeters. So I'm just going to put the values here. So theta is 60 divided by 360 and pi r is 5, which is 5 squared. So that's going to be 1 by 6 only, and pi 5 squared is 25. Pi can be written separately, pi 25 by 6. That is the area. So area should be in square centimeters. Now we need to look at the area of the triangle. Area of the triangle whose two sides and one angle between two sides is given. And we know the two sides are actually the radii. So first radii is, if I say that is equal to A, that is equal to B side. So I'm going to say A is equal to 5, B is equal to 5, and angle which is theta in between them, which is equal to 60 degree. So here we have 1 by 2. AB is equal to 5 times 5, which is equal to 25. Sine 60 is square root of 3 by 2. And be careful that we need to make the answer in this form. Now the denominators will be multiplied with each other. 25 square root of 3 divided by 4 squared centimeter. That's the area of the triangle. So what do we need to do to find out shaded area? We just need to subtract the area of the triangle from the area of the sector, we can get the shaded area. So shaded area is equal to the area of the sector minus area of the triangle. 25 pi by 6, and the area of the triangle is 25 square root of 3 by 4. So we just need to subtract them. So 12 is the least common multiple. So 6 2s are 12. So 2 will multiply by 25. So that's gonna be pi. 25 times 2 is gonna be 50, and minus 4 3s are 12, and 3 will multiply by 25. So 25 3s are 75, and square root of 3 will remain same, square root of 3. So I think so we have made the answer into certain form, which is a pi minus b square root of c divided by 12. So we can say that pi times 50 minus 75 square root of 3 divided by 12 squared centimeter, because that's the area, so it should be in squared centimeters. Here is the graph of y is equal to cos x, where x is greater than or equal to 0, less than or equal to 360. If I put x is equal to 0 here, so y is equal to cos 0. Cos 0 is 1. Okay, so it means at point 0, if x is equal to 0, so the value of y is equal to 1. So that is the 1 point. And now I'm going to put y is equal to cos 90 degree, because angles on the x-axis and the numbers on the y-axis. Cos 90 is 0. That is the point. Similarly, if I put cos 180, so we know cos 180 is negative 1, and you will see that the graph of cos and a graph of sine always comes in between negative 1 to 1. It always fluctuates between negative 1 to 1, negative 1 to 1. The highest value is 1 and the lowest value is negative 1. Y is equal to negative 1. So at cos 180 degree, so the value of y is here, negative 1. Similarly, y is equal to cos 270, and we know 270 also equal to 0. So that would be the point at 270. So if I consider that is 0 degree, that is 90 degree, that is 180 degree, that is 270 degree, 360 degree. So cos 0 is 1, cos 90 is 0, cos 180 is negative 1, cos 270 is also 0, cos 0 is 1, and cos 360 is also equal to 1. That's how we got this graph. So now the question is, in part A and B, the graph of y is equal to cos x is shown as dashed line. So in A part, what we need to find out, on the grid below, draw the graph of y is equal to cos x minus 90, where the values of x is from 0 to 360 degree. Before we had the graph y is equal to cos x. Now we have x minus 90. So if I put x is equal to 0 here, so y is equal to cos 0 minus 90, which is equal to cos minus 90. Cos negative x is also equal to cos x, and sine negative x is equal to negative sine x. So if we have negative 90, that is also equal to cos 90 degree. We can write this as cos 90 degree. So cos negative 90 or cos 90 both have the same value, which is equal to 0. So now in this case, when x is equal to 0, we are getting y is equal to 0. That is the point. And for second point, I need to put x is equal to 90 degrees. So that's going to be y is equal to cos 90 minus 90. So that's going to be cos 0. Cos 0 is 1 when x is 90. If I combine these two lines, that would be the point. Similarly, y is equal to cos 180 minus 90. That's going to be cos 90 again. And cos 90 is equal to 0. So that would be the point. And similarly, we can go like this. At 270 we will get negative 1, at 360 we will get 0 again. So that would be the graph like this. So in the B part, we have function y is equal to 1 plus cos x, and again we need to draw the graph for x is equal to 0. So y is equal to 1 plus cos 0. Cos 0 is 1. So that's going to be 1 plus 1, which is equal to 2. So when x is equal to 0, the value of y is equal to 2. So that would be the point. And when x is equal to 90, let's going to see. So y would be equal to 1 plus cos 90. And cos 90 is equal to 0. So that's going to be 1 plus 0. That's going to be 1. So y will be 1. So x is equal to 90 here, and y is equal to 1 here. That is the point. And now I'm going to put 180. So x is equal to 180. So that's going to be y is equal to 1 plus cos 180. So cos 180 is negative 1. So that's going to be 1 minus 1. We got the value of y is equal to 0. So it means when x is equal to 180, y is equal to 0. So that would be the point. And similarly, if I put x is equal to 270 in equation number 1, so that's going to be y is equal to 1 plus cos 270. And we know cos 90 is 0 and cos 270 is also equal to 0. So that's going to be 1 plus 0. That's going to be 1. So y would be equal to 1. So y is equal to 1 here. And similarly, for the next, we're going to go here. So that would be the graph. in this position. Rita tries to draw the graph y is equal to cos negative x. Here is her graph. That is her graph. Give a reason why Rita's graph is incorrect. Y is equal to cos x and y is equal to cos negative x. They are the same. And if I put x is equal to 0 here, so y would be cos 0. That's going to cos 0 is equal to 1. So y would be equal to 1. It means at x is equal to 0, the value of y should be 1, not negative 1. That graph is wrong because she confused with negative x and the positive x. I'm going to write here as the graph of as cos x is equal to cos negative x. So the graph of cos x and graph of cos negative x should be same, which is the mistake of Rita's graph.